Good morning, juniors. Today we're going to finish with the last part of electronic assignment number 18, which is about the normal distribution. And we're going to see some exercises to finish understanding what this concept is about. Up to now, if you remember, we've seen all the theoretical part of the normal distribution. And we've done this first exercise in which we covered a variable which is normally distributed, but remember, whenever we have the C here in front, it means that we're talking about a special type of normal distribution, which is the standard normal distribution. And the particularity that the standard normal distribution has is that it always has a mean of 0 and a standard deviation of 1. So what I wanted to do today with you is to see other exercises where we do not have, where we have a variable which is normally distributed, but it's not a standard normal distribution, but rather has a different value for mean and standard deviation. And you'll see that it's exactly the same thing. So let's go down. These are the GDC instructions. So it says probabilities for other normal distributions. Clearly, however, very few real-life variables are distributed like standard normal distribution, which has a mean of 0 and a standard deviation of 1. But you can transform any normal distribution, for example this, right? Any normal distribution to the standard normal distribution, because all normal distributions have the same basic shape, but are merely shift in location and spread. This is something very important, right? We can always convert any type of normal distribution to a standard normal distribution in order to be able to solve problems. And you will be understanding this later on in future examples that we're going to be doing, in which you see that it is necessary to convert our variable to a standard normal distribution in order to be able to solve the problem. Okay, it says to transform any given value of x of this normal distribution to equivalent standard normal distribution, we use this formula, which is available in the formula booklet. It says the C value is equal to the x value minus mean, minus minus this mean, right, over the standard deviation of our normal distribution, right? Okay, it says you can then use your GDC to find the required probability. If x is normally distributed with a mean mu and a standard deviation sigma, then the transformed random variable C is found this way, the same formula. And it says it has a standard normal distribution. So we're going to see how this concept applies to the following problem. And you'll see that it's exactly the same thing, but as I told you, you are going to be having to apply this formula later on in future examples that we're going to be seeing. Okay, so it says the random variable x has a normal distribution where the mean is 10 and the standard deviation is 2, or the variance is 4, right? Find the probability of x being between 9.1 and 10.3. Okay, so I'm going to show you two ways in which we can solve this. One is the shortest, which is directly using GDC. So I'm going to write it here. Using our calculator. I'm going to show you this in a second. Basically, if we do a sketch of the problem, we're going to have the following. If we do our normal distribution, let me do it here. This is the x-axis, and we will have the normal distribution, which would be something like this. Remember, this is always a sketch. Something like this. Here you go. So the mean in this case is 10, right? So the value in the middle would be 10. And then we have a standard deviation of 2. So we're looking for this probability being between 9.1 and 10.3. So 9.1 is a value to the left of 10, right? So we can make a sketch, right? Somewhere around here, for example, 9.1. And 10.3 is a value above 10. So it will be somewhere around here. Remember, this is only a sketch. So what are we looking for? We're looking for the probability in between those two values. And that's the area in between the two values, right? So this is the probability that we're looking for, the area underneath the curve for this interval. Okay, so if you remember how to use calculator, if you take a look at the calculator now, we would go to menu statistics, dist, right, distribution, normal distribution, and we're still using NCD for this. So for lower, we would have as lower 9.1, right? That's our lower boundary. And as the upper boundary, we would have 10.3. Now the standard deviation for this problem is 2 and the mean is 10. That's the only thing that changes with respect to the last thing we did, right? So we click on solve and there we have the probability. So let me write this information first. We said that we had as lower boundary, we're going to put the value 9.1. Then as the upper boundary, we're going to put the value 10.3. Then as the standard deviation, we set 2. And as the mean, we had 10. So by plugging in all of that information, we get a probability of the x value being in between 9.1 and 10 and 10.3, which is equal to, let me move this a little bit, here, which is equal to, according to our calculator, this is equal to 0.233. Okay, so that's the probability of this variable being between 9.1 and 10.3. So you see, it's exactly the same thing. But now I wanted to show you another way of solving this problem, which is using the standard normal distribution. Okay, so I'm gonna divide this or use another color. Another way to solve this is using standard normal distribution. Let me show you what this is about. It's actually not necessary for this problem to work it this way because we could just use work this way, which is much shorter. But I'm showing you this because in future problems that we're going to be solving, it will be necessary, and you will understand later on why. Okay, so if we use the standard normal distribution, we need to consider this formula. The C value is equal to the X value minus mean over standard deviation. Okay, so in order to convert the X value to the C value, I need to consider these two boundaries, the lower boundary and the upper boundary. I need to convert each of these boundaries to the equivalent C values for this situation, okay? So what I'm going to do is the following. I'm going to write C using 9.1 as our first C value. So this would be, instead of X, we're going to write 9.1, which is the first boundary we want to convert. We want to standardize, that's the term that is used, minus the mean, which is 10 in this case, over the standard deviation, which is 2 in this case. If I solve this using the calculator, you would see we would get a value, a C value of negative 0.45. That would be the value you will get. So this means that is negative 0.45 is the equivalent value of 9.1 for this situation. We're going to do a sketch later on and you will understand. Then if we find the equivalent value for 10.3, which is the upper boundary for this problem, we're going to apply the formula and say that this is 10.3 minus 10 divided by 2. If you solve this using your calculator, you will get the equivalent C value, which is 0.15. Okay, so what does this mean? If we do a sketch of the standard normal distribution, remember a standard normal distribution always has a mean of 0 and a standard deviation of 1, right? So if we do the sketch, we're going to have exactly the same curve, the same shape, because we're talking about normal distribution always. But now our new mean, remember the standard normal, if you write it here, the standard normal distribution has always a mean of 1 and a standard, sorry, a mean of 0, and a standard deviation of 1, okay? So that means that this value in the middle is 0. This value to the left is negative 0.45. You see, that's why we get a negative value there. And the value to the right would be 0.15. So this standard normal distribution is the equivalent of this normal distribution for this particular problem, okay? So let me write the following step. Once we standardize the values, we need to find the probability of being in between these two values, right? In between negative 0.45 C and 0.15. So if we find these probabilities using our calculator, we're gonna do exactly the same, but now as lower, we need to write negative 0.45. As the upper, we would write 0.15. Now our standard deviation would be equal to 1 because we're talking about a standard normal distribution, and our mean would be 0, okay? Let me show you this in the calculator. You see that we should get exactly the same result. So if you take a look at the calculator, we're gonna go back. Now as lower, we're gonna write negative 0.45, and as upper, we're gonna write 0.15. Our standard deviation is now 1 and our mean is 0. So we click on execute and you see that we get exactly the same value, right? So let me write this down. We're gonna say that the probability of being between 0.45 C and 0.15 is exactly the same value, 0.233. So that's a clear example of how you can work with either the original normal distribution, the one that the problem is given, or you can convert to a standard normal distribution and work it that way as well. Either way would be fine, right? In our case, since we have the graphic display calculator, we can already do it this way. But in some cases, where there are calculators which do not have the option of changing a mean and standard deviation. So in those cases, you would have to use this method, okay? And later on, we're gonna see problems where we will need to apply this method because there's no other way of solving the problem. Okay, to finish, we're gonna see this last example. It says, eggs laid by a chicken are known to have the mass normally distributed with a mean of 55 grams and a standard deviation of 2.5 grams. What is the probability that an egg weighs more than 59 grams? B, an egg is smaller than 53 grams, and C, an egg is in between 52 and 54 grams. Okay, so this is quite easy. It's just a real life application of normal distribution. Let's identify our information first. We know that the mean in this case, according to the problem, is 55 grams, and that the standard deviation is of 2.5 grams. So if we want to write it, it tells us that it's normally distributed, so we can write this as X is normally distributed with a mean of 55 and a standard deviation of 2.5. Remember here we need to write the variance, so we're going to write 2.5 squared, okay? That's how we represent the normal distribution. So for part A, we want the X to weigh more than 59 grams. So I think we don't need to do the sketch anymore. I think you can already interpret this. But if I do it quickly here we'll have 55 in the middle and 59 would be a value here to the right. And we're looking for this area over here, like, right? The one that weighs more than 59 grams. So that's exactly what we're going to do. Our lower boundary would be 59 and the upper boundary would be positive infinity. Okay? So we already know what to do here. Let me write the information. If we're looking for the probability of X being greater than 59, then we're going to have as lower boundary, this would be 59, The upper boundary would be a positive infinity, right? 9 times 10 to the power of 99. Our standard deviation is 2.5, and our mean would be 55. So if we do this in the calculator, we're going to go back. Our lower, we said it's 59. The upper is 9 times 10 to the power of 99. Our standard deviation is 2.5, and the mean is 55. We click on execute, and there we have the value, right? So the probability of x being greater than 59 is equal to 0.0548. Okay? Then, if we move on to part B, just a second. Okay, so if we move on to part B says the following. An egg is smaller than 53 grams. So basically we're doing the same thing, but now we're looking for the probability of x being less than 53, right? We don't need to do a sketch for this. We already know what we need to do. In this case, our lower boundary would be negative infinity, right? Because it's values less than 53. So negative infinity, negative 9 times 10 to the power of 99. Our upper boundary would be 53. Our standard deviation would be 2.5, and the mean is equal to 55 as always. So with this information, we just need to change some things in the calculator, and we would have the probability of x being less than 53. So this would be, if we go back into the calculator, lower would be negative 9 times 10 to the power of 99. Upper would be 53, and finally this is the same thing, so there we get the value. 0.212 is the probability of x being less than 53. This is the answer for part A. Finally, for part C, it says an egg is in between 52 and 54. Okay, so in this case we have both the lower and the upper boundaries, right? So the lower boundary, sorry, let me write this first using mathematical symbology. We need to be in between 52 and 54. Yes, so our lower boundary, in this case would be 52. The upper would be 54. The standard deviation is 2.5, and the mean is equal to 55. So with all of this information, we can find this probability, which if we go to the calculator, we would write our lower would be 52, the upper would be 54, standard and mean are the same, and there we get the value. The probability of lying in between these two values would be 0.230. 0.230 if we round this to three significant figures. Okay, so I think that's it. We have a hint right here, which says the following. This is what I explained to you. Some GDCs allow you to calculate the probability of other normally distributed random variables directly, which is our case, right? We can do this with our calculator. You must enter the mean and standard deviation into your GDC. If you can do this, it is the quickest and most efficient method to use for this type of question. However, you need to know how to use standardization in order to answer other types of questions later in this chapter, which is something that we're going to be looking at in future live sessions, okay? So I hope this was clear, juniors. If not, please let me know. We're going to clear doubts in future live session. Thank you for your attention.